All right, so yesterday we had a great opportunity to start talking about units and measurement and scientific notation, et cetera, et cetera, et cetera. Today we're going to really get into talking about dimensional analysis or unit analysis, used in both ways. And this really is a problem-solving method that you can use in many different areas, one of them being chemistry. And I want to make sure to make something clear, and that is with this problem-solving method, there's not one avenue to take. There are actually multiple avenues that you could take, and you can look at things different. You can start with what you're looking for, you can start with what you have, et cetera, et cetera, et cetera. So understand that when I talk about it in the way that I do it, it might be different than the way that your teacher does it, or that you end up doing it, and that is perfectly okay. As long as you understand the basics of it, which is that we are taking a bunch of factors, which are values that are equal to each other in terms of the actuality, but might have different numbers. And you're canceling to get to the unit that you need to answer that particular problem. And so the first thing we need to understand is these factors, okay? If I was to ask you, what is greater, 1 foot or 12 inches, what would you answer? And hopefully by the time you're in 10th grade, you would say, well, those two things are equal. 1 foot is equal to 12 inches. Those two values are the same thing. The numbers aren't the same, but because of their different units, the actual values of them are the same, okay? And when we have things like this, we can use them in order to factor out units that we don't want to use into units that we do want to use. So with this then, I could put this into any equation, okay? And I like to draw them with this around them, but different teachers are different. And I can put 1 foot over 12 inches. And the value of this then is what? What is the value of this right here? Well, it's 1. They're the same thing. So anytime you can put something on top or something on bottom and get a value of 1, you can use this as a factor to help you in your dimensional unit analysis. In the same way, what would be the value if I put the 12 inches on top and the 1 foot on the bottom? What would be the absolute value of that? Well, it would be 1. The answer is it would be 1, okay? So I can use these to answer different questions. I'm going to start with using my prefixes. So if we go back and we remember our prefixes and we remember our mnemonic saying or remember anything else that we say, we could ask a question like, how many centimeters are in 1.5 kilometers, okay? Let's start with that one, okay? Now the way I do this is very specific, and your teacher again might do it different. But when I'm solving it with any kind of problem like this, the first thing I do is go long line equals short line, okay? And I set this up the same, and again, this harkens back to 1987 and my high school chemistry teacher. Shout out to him. Now I'm forgetting his name. Oh, Mr. Hardy. Mr. Hardy was awesome. He scared the crap out of me. The dude grew hair everywhere. And he had it almost looked like his nose had curtains. His nose hair was that long. He's very intimidating, but he's a really bright, brilliant man. Long story short, after I draw that long line equals short line, I asked myself, what am I looking for? What am I looking for specifically in terms of units? Well, in this case, I'm looking for centimeters, okay? And for me personally, I'll ask myself at this point in my life, like, okay, centimeters is a unit of distance. Do I have anything that's related to distance? And I go, yes, I do. I have 1.5 kilometers, that's distance. Back in the day, I didn't even do that. I just went back and kept checking the value I was given to see if I could cross it out. So either way. Then I asked myself, well, what do I know about centimeter? Well, I know centimeter. What does that mean? What does centi mean? And if you remember yesterday, our little thing, centi means 10 to the negative 2. or 1/100th. That's what it means. So I go centi literally means 10 to the negative 2. So it would make sense for me to just put 10 to the negative 2 right under centi and then put meter. So if I do that, 10 to the negative 2 meters and a centimeter are the same thing. So their value is 1, so I can use it as a conversion factor, okay? So now I have the unit that I want on top. I circle it, I go, yep, there it is. Whee! And I go, now it goes back to meters. Well, I ask, am I given meters up here? No, I'm given kilometers. So again, I go, when I see prefixes, I say, well, what do they mean? Well, kilo, what did that mean again? Let me see, what did it mean? 10 to the second? No, 10 to, oh, that's right, it means 10 to the third. So writing 10 to the third, excuse me, I almost screwed that up. I put 1 kilometer on the bottom because I need to cross out kilometers here. And what does kilometer mean? It means 10 to the third, what? Meters, okay? So after I've done that, again, I go, here's my next conversion factor. These two numbers are equal to each other, the same thing, so their absolute value there is 1, so I can go ahead and use that. And now, I just go back to what I've learned about basic algebra, whereas if I have the same value on the top and the bottom of an equation, I can cancel them out. So meter on top, meter on bottom, those cancel. Kilometer on top, kilometer on the bottom. Now I can go through and I can type 1.5 times 10 to the third, or 1 times 10 to the third, times 1, that's 1, divided by 1, divided by 10 to the negative second. I could type that into my calculator, and kids do it different. And often kids start to be able to set these up, but I'll see often they'll have it set up correctly, but they'll give me the wrong answer because they forget their order of operations that they learned. So be careful with this as you're going through. There are some other ways that you can do it, like understanding when you're dividing two of the same base numbers with exponents, you just subtract. So for this, I have times 10 to the raised to the third divided by times 10 raised to the negative second. 3 minus a negative 2 is 5. So I can just say 1.5 times 10 to the fifth, okay? 1.5 times 10 to the fifth, and I'll get my answer. So there's a conversion right there. What is the rule if I'm multiplying exponents? So if I had instead, okay, totally different problem. But if I just had a circumstance where I said, and I'll change numbers so as not to confuse anybody. If I had 12.3, and I'm not even going to include units here because I'm just doing it for next, times 10 to the third, times 2 times 10 to the negative second, okay? So as I'm going through and doing that, I can multiply these numbers up here, okay? And I get 24.6, and I'm gonna do this just so I keep my significant figures here, right? And then I have times 10 to the third times 10 to the negative second. I add those two things together. So how do I add them? I just add the exponents. 3 plus a negative 2 is equal to 1. So it's 24.6 times 10, okay? Which is implied to the first power, or 246 would be the answer there. And again, any way you look at it, that's the way you're going to go. So with those conversions, we'll have a lot of different practice between metric conversions, and this is why it's really important to be able to know the value of those prefixes. What are those centi, milli, deci, nano, pico, etc.? What do they mean? What do they mean? What numbers do they mean? Okay. How about if we're outside of that? Okay, we're not expecting you to necessarily remember the conversion of miles to kilometers, or maybe some others as well. But you should definitely then be able to use them if they're given to you, okay? So if I give you something like 5,280 feet is equal to 1 mile, and I was to say 1 mile is equal to 1,609 meters. So let's say I gave you those two things, and I said, had a question that said 2.5 times 10 to the 6 centimeters equals how many miles, okay? So let's imagine that right now. Now it's not just metric conversions, it's others, but we're still following the same rule, which is number one, long line equals short line. What am I looking for? I'm looking for miles, okay? I'm just gonna start with that. And I say, well, what do I know about miles? Well, I know right here, it says 1 mile is equal to 5,280 feet. And I have one that says 1 mile equals 1,609 meters. So I go, which one do I use? Do I use them both? And how do I get it? And that's when it's important for you to go back and say, well, what am I given? I'm given centimeters. I'm given centimeters. And this takes some time because you got to say to yourself, what does that have to do with feet? Do I know any there? And maybe you do. Maybe you know that there's 2.54 centimeters in an inch, okay? And I know there's 12 inches in a foot. And certainly you could solve this problem doing that. And that's where I'm saying there's more than one avenue to do it. But it would be a shorter step to say to yourself, well, I know that 1 mile equals 1,609 meters, okay? And again, those two values are the same, so I can put them there because their value is 1. Well, what do I know about meters? Well, what I do know is that if I start with 2.5 times 10 to the 6 centimeters, I do know what centi means. Again, if you remember from last time, centi means 10 to the negative 2. Meters is a centimeter, okay? And now I got to look at that and I ask myself, is that going to work? And I would say no, because now I have centimeters and centimeters on top and meters on the bottom. So when I go, which one do I put on top or bottom? Well, I'm trying to get rid of those ones because I've already identified the unit that I want to solve for. So while this is like this and it's perfectly acceptable, it won't work for my problem. My units would end up being centimeters squared times miles divided by meters squared. That's not what I'm looking for. I'm just looking for miles. So I'm going to flip this upside down. 1 centimeter is equal to 10 to the negative 2 meters. Now my centimeters cancels and my meters cancels, and I can end up in miles by multiplying everything on top and dividing by everything on the bottom. And again, I could put that into my calculator and go from there, but that's how we're going to set those up. Just a quick reminder for when we're doing dimensional analysis and we're dealing with squares and cubes, most often with distance, because when we have a square distance, then usually we're talking about a term called area, which I'm sure you've heard before, okay? So like the area of a room is often taken into account, okay? Your floor space. When we look at houses, you say, oh my gosh, that person's got a 10,000 square foot house. Okay, that means the floor plan, the amount of floor available is 10,000 feet in one direction and 10,000 feet in another direction. Okay, that squared goes up there. Well, how do we do that in terms of doing conversions here? And I want to remind you of something here, and that is that you have to account for each of those particular measurements. Okay, 10 to the negative third centimeters cubed is not equal to 1 meter cubed. So what am I going to show you here? Or I should say 10 to the third centimeters cubed isn't equal to 1 meter cubed. So let's take a look at what that means. And I like to do it and say, well, what does it mean when we square a unit or when we cube a unit? It means the same thing when we do it with a number. So for instance, if I was to write 2 squared, what does that mean? It means 2 times 2. If I was to write 8 cubed, that means 8 times 8 times 8. So if I was to write centimeters squared, that means centimeters times centimeters. That's what it means. So when I'm doing conversions, that really help me to not get confused and be doing it in my head. And there's, again, certainly shortcuts. Again, I write my long line and short line and say, what am I looking for? I'm looking for centimeters squared. And then I ask myself, what do I know about centimeter? Well, I know that centimeters squared, and sometimes I'll even write this, is equal to centimeter times centimeter. So I need a centimeter on top and another centimeter on top, okay? And what do I know about centimeter? I know that centi means 10 to the negative 2 meters. 10 to the negative 2 meters. Now, these two units are equal to centimeters squared, and I just got to get rid of that meters squared, okay? What am I given over here? I'm given 2.1 times 10 to the negative third kilometers, excuse me, I got to go back up to here. I'm mixing two problems together, my bad. I have 4.3 times 10 to the third meters squared. So that's 4.3 times 10 to the third. And I'm going to write meters times meters, because that's what meters squared means. And again, now I have meters on the bottom, meter on top, a meter on top, a meter on the bottom. They cancel out. 4.3 times 10 to the third divided by 10 to the negative 2 divided by 10 to the negative 2. And what does that mean again when we have exponents and we're dividing? We subtract. So it's 3 minus a negative 2 minus a negative 2. So 3 minus a negative 2 minus a negative 2 ends up being plus 4, right? So 3 plus 4 is 7. So my answer is 4.3 times 10 to the 7th on that particular problem, centimeters squared. We have to make sure that we show both. So using that logic, go ahead and pause this video and try to do that one. 2.1 times 10 to the negative third kilometers cubed equals how many micrometers cubed? Remember that fun little Greek thing, I think it's mu, stands for micro. And remember what micro means. Okay, pause, do it. Okay, you've paused it, you're coming back, you want to say, did I get it right? What did I do? Okay? Again, quickly, long line equals short line. I'm looking for micrometers cubed. Okay? Micrometers cubed means micrometer times micrometer times micrometer. And again, for me, sometimes it's just easier for me to write it 3 times. Okay? And then on the bottom, put what micro means. What does micro mean? It means 10 to the negative 6. So 10 to the negative 6. 10 to the negative 6 what? Meters. And a micrometer is equal to 10 to the negative 6 meters. Because it was micrometers cubed, we had to write it in 3 times. And again, so I have my 2.1 times 10 to the negative third kilometers cubed, okay? And so, like I said, if you were looking at this, you could probably start to figure out in your mind 1 cubic micrometer then is equal to 10 to the negative 18 cubic meters. So I'm going to take that same logic and I'm going to do it for kilometers cubed. So I'm going to say a cubic kilometer is equal to what then? Well, if a kilometer is equal to 10 to the third meters, and it's 3 times, what would that be? Okay, well, 10 to the third times 10 to the third times 10 to the third, right? When I'm multiplying exponents, I actually add them. So 3 plus 3 plus 3 is 9. So that's, 10 to the 9th meters, okay? So my kilometers cubed cancels, and my cubic meters cancels, and I have 1, 2, 3 here, boom, boom, boom. They're all multiplied by each other. That means micrometer cubed. And now I just solve. So let's do that again, just for a nice exercise with exponents. 2.1 times 10 to the negative third times 10 to the 9th. Again, when multiplying exponents, I add them together. 9 plus a negative 3 is 6. And now I'm dividing that 6 by negative 18, which means I subtract. So 6 minus negative 18 is like 6 plus 18, which is 24. So it's 2.1 times 10 to the 24th. So if you practiced it and you got that, woo! If you didn't, see what you did wrong, keep practicing. Guys, this kind of problem solving it takes practice to be good at it. It takes continued practice. So I understand that some of this is going to seem like busy work, and it's really not. It's no more busy work than in basketball practice practicing shooting free throws, okay? You know how to do it, but it takes practice to get good at it, to be able to continue to do it more quickly, to do it in faster situations, okay? So, dimensional analysis, problem solving, a big thing we're going to be working through all year long. Thank you.